Vlog Boy here, and we are watching 142 Nonillion Degrees. What would happen next? Which is made by um, the Real Life Lore, who's a scientific YouTuber, and I like his content. Many other people actually like his content as well. So if you don't know what a nonillion is, it's a number. Obviously, it's a number that is so big that really no one knows it besides me and probably about 2 other million people. But it's over a trillion. It's over a quadrillion. It's over a quintillion. It's over an octillion, so it's the next number after an octillion, I believe. So it's huge. And the video is provided by Brilliant, which I've tried using before, and it's actually pretty cool, but not as easy as you think scientifically or YouTube-wise, But we're going to, just play the video because I know you guys hate me talking because you think I'm dumb, which I can't say I am because I am not dumb. I am big brain compared to a lot of my friends. So let's continue. Well, let's go.
Brilliant. Start learning intuitively with Brilliant for 20% off by being one of the first 200 people to sign up by clicking the link in the description. So the title of this video is What Would Happen If the Temperature Somewhere Reached 142 Nonillion Degrees, which, for reference, has this many zeros. The answer is...
Let me go back just for a second. I know you can use the bracket keys, but frick that. Okay.
42 Nonillion Degrees, which, for reference, has this many zeros.
Do you see how many zeros I was talking about? That's, okay, you can't really see it through, me pointing. But you can obviously...
The answer is weird, but to prepare you for it, we need to start with some weird things that happen at much lower temperatures. We can begin our journey at negative 273.15 degrees Celsius, also known as absolute zero or the coldest possible temperature in the universe. In 2003,
I beg to differ on that because I feel like temperatures could get 10 times colder than that. Which, by reference, let me pull my calculator up because I'm big brain, obviously, and don't need a calculator because I don't clearly have it. But if we go 273.15 degrees negative and we multiply that by 10, I feel like temperatures could get to to a coldness in the whole entire universe that I know of to around negative 2,731.5 degrees Celsius, which is beyond freezing. So I beg to differ that it could get way colder than just 273.15 degrees Celsius negative. I beg to differ that, but okay.
Scientists at MIT came very close to achieving this temperature when they got just a billionth of a degree above the limit. That means that the coldest temperature ever observed anywhere in the universe was actually just right here on Earth in this laboratory.
But understand, you're saying...
Just barely above that, at negative 273 degrees, is the lowest temperature ever survived by a living thing, the cute but almost indestructible tardigrade or water bear. Once we get a little warmer to negative 216 degrees, we arrive at the coldest planet in the solar system, Uranus. Warmer still at negative...
Yes, it is pronounced Uranus. Do not...
4 degrees is the average surface temperature on the dark side of the moon, and just 1 degree higher is when oxygen starts to boil. Earth is comparatively much warmer than most other planets, because the coldest temperature ever measured here naturally was negative 89 degrees taken at the Vostok Station.
Negative 89 degrees.
Station in Antarctica. The lowest temperature ever recorded in the US was negative 62 degrees in Alaska, which is even colder than the average surface temperature of Mars is at negative 55 degrees. Finally, at 0 degrees, we reach the melting point of ice, and just slightly higher at 13.7 degrees is the lowest body temperature a living human has ever had. The average...
No. People have lived beyond... I had to go through a whole entire day in negative 16, so do not say any of that bullcrap saying only 13.7 is what you can live at. No, I had to go through a day, not with the right equipment, at negative 16, and I lived through that barely. So don't say that I couldn't live beyond or below 13.7, because that is false. That is false evidence. And it depends on the person too. It really does. You're saying average person. Well, that depends on how average you may be. But I am not average because I had to go through a whole 24 hours of negative 16 degree temperatures. So that's still BS to me. So continue.
Average human body temperature is 37 degrees, and 46.5 degrees is the highest recorded body temperature that a person has survived.
I don't know. I can.
57 degrees is the highest temperature recorded in the US, taken in Death Valley, while 71 degrees is the highest surface temperature ever measured anywhere on our planet, taken inside of Iran. But there are places out there in the universe that are far hotter than anywhere on Earth. Despite how cold the moon is on the dark side, the average temperature where the sun does shine is a sweltering 101 degrees. Despite these two opposite climates, the tardigrade I mentioned earlier could survive either of them. The highest temperature that one has survived was an amazing 151 degrees, but the universe still gets way hotter. 462 degrees is the average surface temperature of the planet Venus, the hottest planet in our solar system.
Well, yeah, it is the hottest planet.
Raising the heat even more up to 1027 degrees, and we get to the maximum temperature of a flame burning from wood. Lava freshly erupted from a volcano can hit 1200 degrees, but candles can burn even hotter up to 1400 degrees. Eventually, we hit the boiling point.
I think I know why candles are actually hotter than lava, is because lava is stored outwards to where it's just everywhere, and the heat kind of just goes into separate parts, versus a candle, the fire is stored all into one impacted place, and that's why like wax will get super hard if you like pour it on something. I think that's the scientific reason of it, so I think that's why it's hotter. Don't
Points of silver, iron, and carbon, and at 5,000 degrees we reach the temperature inside the initial blast of a conventional chemical bomb. The temperature you would encounter at the surface of the sun may seem very high at 5,500 degrees, but the temperature inside of the Earth's core is even hotter at 6,000 degrees. But hotter than either of those is the temperature inside the fireball of a nuclear explosion, which can be up to 10,000 degrees or even more. But outside of the sun's surface, the sun's upper atmosphere can reach an unbelievable 1 million degrees. Down at the sun.
Did we just go from 6,000 Celsius to 1 million? Seriously? We just took a jump 2 or 3, 4, 5 times bigger than what we were basically starting at. And of course, it's the sun, so what did you expect? And we're buffering. I'm sorry, my internet's trash. In editing, you won't see this, but
at the sun's core, the temperature can reach an even more insane 15 million degrees. But that's nothing compared to the heat generated from the blast of a supernova. When a star enters
okay, if you want to know if it loads
into a supernova state, it heats the gas around it to a mind-boggling 55 million degrees. When smaller stars collapse into neutron stars, though, the newly formed neutron core has a temperature approaching 100 billion degrees, which is 6,666 times the temperature found inside of the sun's core. But the hottest temperature ever recorded anywhere in the universe was right back here on Earth, created by scientists at CERN in Switzerland. Using the Large Hadron Collider, they created extremely fast collisions of lead ions that briefly generated a temperature of 5.5 trillion degrees, which sounds like a lot, but it was limited to a very tiny area around where the ions collided. But the hottest temperature that might be possible in the universe is completely unbelievable. 142 nonillion degrees is the temperature at which our conventional understanding of physics begins to break down. In theory, there is no no limit to how much energy we could put into heating something up, but there so far is no scientific theory for how matter might behave at this high of an energy level. We simply don't know what would really happen if we managed to heat something up this hot, but we can speculate a little. This temperature is known as the Planck temperature because the radiation emitted from
If you don't know what the Planck temperature is,
an object this hot would have a wavelength equal to the Planck length, a distance so unbelievably small that we don't know how or if we can measure distances that are smaller. Because you would be condensing so much energy into such a small point, going beyond the Planck temperature could be enough to turn the area or thing you were heating into a black hole. Creating a black hole with energy instead of mass like this is called
which
a
has actually
blitz,
happened.
and it could pretty quickly become a bigger problem than whatever damage the heat would have caused to you. Our math so far can't describe what exactly would happen if we went beyond the Planck temperature. It may create a black hole that would instantly radiate away, or it could destroy the Earth, or it may do something else completely unexpected by anybody. The mathematical models that we've developed so far are incapable of explaining it. But if you'd like to take your shot at it and go down in history as a scientist celebrity, you'll need an understanding of things like calculus, quantum mechanics, and general relativity. The numbers and concepts.
Things that are so hard to learn that not even a scientific genius with an IQ on only this matter of over 300 could still get the answer of. Couldn't do it.
Steps that go into learning these things are hard and confusing for a lot of people, including myself, but taking the courses over at Brilliant.
Okay, so he's just talking about Brilliant, which is like what he shared about. And I've actually done it, and it's not easy. Because the math in it is so beyond hard. I don't know anyone at all, as a friend or who I've known as, who can even explain stuff like this because they probably never even heard of it. But you can go try Brilliant out. I'll leave it in the description. It might not even leave a link. I'm not sure. That's this. You might have to sign in though, because I've had to sign in. So I don't know. Maybe you have changed over time. But yeah, that is it. I don't know why my computer is acting weird. Sorry if it's being buggy, because if it's being buggy, I would really hate to have to record this again. Why aren't you working? Oh, there we go. Okay. So if you guys want to go check out Brilliant, I will leave it in the description. If you want to check out anything else listed from the real life lore, you can do that as well. Subscribe to his channel if you haven't either, because he has big brain compared to me, even though I have a basic knowing of, or trying to know of what I know about this stuff. Otherwise, subscribe to my channel, me, Vlogger Boy here, and all my separate channels, other channels, friends' channels, like the video, do all that. And until then, I'm going to go because editing this is going to be a worse nightmare than probably anything else. But I'm not going to do it today. I'm going to edit it sometime whenever I feel like it. But if you want me to do other videos like this, leave a comment or leave a like down in the description and give me something on my Discord or on the comment section to what I should react to next, resolving around the real life lore or anything else appropriate, of course. And until then, I will see you guys into the next video. I will see you guys. So, goodbye.